This section is on rectangular solids. Here are the things you will learn. You will learn to find the volumes and surface areas of rectangular solids and cubes. You will also learn to find their diagonals. You will also understand what happens to the total surface area and volume if two rectangular solids are formed by cutting the original rectangular solid in two. Things to remember: a rectangular solid has three dimensions, length, width, and height, and the opposite faces are congruent. The top and bottom faces are congruent, the front and back sides are congruent, the left and right sides are congruent. Here are the formulas you will need. The volume of a rectangular solid V equals LWH, which is length times width times height. Obviously, L is the length, W is the width, and H is the height. The surface area of a rectangular solid is 2LW plus 2WH plus 2LH. The volume of a cube is V equals S cubed. The surface area of a cube is 6S squared. The diagonal of a rectangular solid is indicated by the dashed purple line. Notice that this diagonal is three-dimensional instead of two-dimensional the way it would be in a flat surface such as a rectangle. The diagonal of a rectangular solid, D, equals the square root of the quantity L squared plus W squared plus H squared. The diagonal of a cube is simpler. It's equal to the square root of 3S squared. Here's example 1. The volume of a cube is 27 inches cubed. Find the surface area of the cube. We solve this problem in two steps. First, we find the side length. Since V equals S cubed, we can take the square root of that formula and find the cube root of the volume equals S. The cube root of 27 equals 3. Therefore, the side length of this particular cube is 3. Now that we know the side length, we can substitute it into the formula for the surface area of the cube. Remember that the surface area of a cube is 6S squared. That gives us 6 times 3 squared, which is 6 times 9, which is 54. In example 2, we've taken the rectangular solid shown below, the one that has a length of 6, a width of 2, and a height of 3. The solid is then cut into two pieces as shown. Notice that the front solid in this diagram has a length and width of 2 and a height of 3, while the second new solid has a length of 4, a width of 2, and a height of 3. To find the surface area, we use the formula. And now remember, what we're doing is we are comparing the surface area of the original solid with the sum of the surface areas of the two new solids. And part A is asking, what is the surface area of the original solid? We use the formula S equals 2LW plus 2WH plus 2LH. Substituting those values gives us 2 times the length, which is 6, times the width, which is 2, plus 2 times the width, which is 2, times the height, which is 3, plus 2 times the length, which is 6, times the height, which is 3. Doing the arithmetic gives us 24 plus 12 plus 36. That equals 72. Now, what is the surface area of the two new boxes made by cutting the original box? Assume that all the sides are closed, right? The surface area of the box in the foreground is 2 times 2 times 2, plus 2 times 2 times 3, plus 2 times 2 times 3. Doing the math gives us 8 plus 12, which equals 32. The surface area of the box in the background is 2 times 4 times 2, plus 2 times 2 times 3, plus 2 times 4 times 3. That's 16 plus 12 plus 24 equals 52. Now we're asked what the combined surface area of the two boxes is. And adding 52 and 32 gives us 84. The take-home message from this part of the problem is that the combined surface areas of the two boxes is greater than the surface area of the original box. And this is example 2 continued. Remember, in the first slide we found surface areas. Now we're finding volumes. And the next question is, what is the volume of the original rectangular solid? The answer is that it's V equals 6 times 2 times 3, which is 36. Now we're asked, what is the combined volume of the two new rectangular solids that were produced by cutting the original solid in two? The volume of the first solid, V, equals 2 times 3, which is 12. The volume of the second solid is 4 times 2 times 3, which is 24. The combined volume of the two solids is 36 cubic units. Notice that the two volumes are the same. The volume of the original solid equals the sum of the volumes of the two new solids formed by cutting that original solid in two. And the next example is, what is the length of the diagonal of the original uncut rectangular solid in example 2? Recall that the length was 6, the width was 2, and the height was 3. The diagonal formula is D equals the square root of L squared plus W squared plus H squared. Substituting into that formula gives us 6 squared plus 2 squared plus 3 squared, which is 36 plus 4 plus 9, which is the square root of 49, which is 7. Here are some practice problems for you to try. Pause the DVD after each problem. When you have finished, come back for the answer. Practice problems part 1. A rectangular solid has a length of 5, a width of 3, and a height of 4. Find the volume, then find the surface area, and find the length of the diagonal. In question 2, a cube has a volume of 125 cubic units. Find the surface area of the cube. In question 3, given the cube in problem 2 above, find the length of its diagonal. Here are the answers. The answer to question 1A is 60. The volume equals length times width times height, which is 5 times 3 times 4, which equals 60. Part B, the answer is 94. We're finding the surface area, which is 2LW plus 2WH plus 2LH. That's 2 times 5 times 3, plus 2 times 3 times 4, plus 2 times 5 times 4, which equals 30 plus 24 plus 40, which equals 94. The diagonal equals 5 square root of 2. We have the square root of 5 squared plus 3 squared plus 4 squared equals the square root of 25 plus 9 plus 16. That adds to the square root of 50. Simplifying the radical gives us the square root of 25 times the square root of 2, which is 5 square root of 2. Here is practice problem 4. We have a rectangular solid shown below. It's then cut into two pieces. Find the surface area of the first box, then find the combined surface area of the two boxes. Which surface area is larger, the surface area of the original box or the combined surface area of the two smaller boxes? Next, find the volume of the first box and find the combined volume of the two boxes. Here are the answers to problem 4. Part A, the answer is 88. The surface area of the first box equals 2LW plus 2WH plus 2LH, which is 2 times 6 times 2 plus 2 times 2 times 4 plus 2 times 6 times 4. Doing the math gives us 88. B, when we've cut these boxes into, we've cut them into two equal figures, and both have dimensions of 3, 2, and 4. Therefore, 2LW plus 2WH plus 2LH equals 2 times 3 times 2 plus 2 times 2 times 4 plus 2 times 3 times 4, which is 12 plus 16 plus 24 equals 52. Because there are two boxes, the combined surface area will be 104. Notice that the combined surface area of the two boxes which was 104, was greater than the surface area of the original box, which was 88. In Part D, the volume is 6 times 2 times 4, which is 48. That's for the original box. Look for the volume of the two combined boxes. The new dimensions are 3, 2, and 4. We multiply those together and get 24. Because we have two of those boxes with the same measurements, the combined volume will be 48. Notice that that combined volume is the same as the volume of the original solid.